Okay, now that we've mastered multiplying polynomials, that was, we went over that in, I think, 5.5, we are going to factor them. This is essentially the opposite of multiplying. So we want to write polynomials as the product of two or more polynomials. This is actually related to factoring whole numbers. So let's review some common terms. So the word factor, and I always use the analogy for factor, is like imagine you have a factory. Okay? What comes out of a factory? Factories produce products. They do, actually. So if you have a factory, you have little pieces, right? You might have a 2 times a 5. Out of the factory comes a product. And the product is an answer to a multiplication. So the factors are the little pieces that happen in the factory producing a product. A number that can multiply by another to get a product. That's the definition of factor. A term is a single number or a variable or numbers and variables multiplied together. They're separated by addition and subtraction. So we were talking in chapter 5 about terms. How many terms is this? 2 terms, right? X plus 5 would be a binomial. Okay, so a single term would be 5x because that would be 5 times x, right? 5x squared y cubed could also be an example of a term because everything's multiplied there. Even something like 5/3 x squared y cubed. That's one term, okay? 2 terms is separated by addition and subtraction. The greatest common factor, otherwise known as the GCF, is the largest number that multiplies into both of the original numbers. Actually, I think it should be divides. Divides. I just wrote down the definition from the PowerPoint, so that doesn't really make sense. The largest number that divides into both the original numbers. So if we're looking here at 18 and 24, can you think of the biggest number that would divide into each number evenly? So 6 would be the GCF because 6 would divide into 18 and divide into 24. So if you divide 18 by 6, you would get 3. If you divide 24 by 6, you would get 4, right? So it's similar. It's a similar concept to if you have a fraction, 18/24, and you reduce it to 3/4, you've found the GCF, you found the biggest number that divides into both. Yes? 72 would be the lowest common multiple. Lowest common multiple you use if you a lot of people get that confused. So lowest common multiple or lowest common denominator. Let's say I had 1/18 plus 1/24. Then I would need to find the lowest common multiple. Okay, but the factor divides in. Okay, so let's look at B. Can you think of a number that would divide evenly into 7, 56, and 91? 7. And I had to actually, I was like, 91. Well, I know that 7 is prime, so 7 would have to be the only number as an option because nothing else is going to divide into 7 besides 1, right? That's what makes it prime. I know 7 goes into 56, and I had to use my calculator to divide 7 into 91. I had a feeling that it went in evenly, and it went in 13 times exactly. Okay, next one, 10, 25, 150. What is going to be your GCF here? 5. Any questions about how we got that? Okay, what about the GCF for 12, 30, and 72? 6, yeah, 6, because 12 doesn't go. See, I would have thought 12, but 12 does not divide into 30 evenly, so that's why 6 is half of 12. Good. It's important to check that our answers make sense by writing out each number as a product of the GCF and some other factors. We can do the same thing. So basically what they're saying here is 12 would be 6 times 2, 30 would be 6 times 5, and 72 would be 6 times 12. Is that right? Yeah, 6 times 12. Okay, find the GCF of each set of terms. Check by writing each term as the product of the GCF and some other factor. So what's the biggest number that's going to go into 3 and 6? Yes, 3. What's the biggest variable that would go into x cubed and x squared? X squared. Because here, this is going to be the same thing as 3x squared times what else would give you the x cubed? Times x. So here's my GCF, okay? Here, this is going to be 3x squared times what is going to give you 6x squared? Times 2. So you can see that that GCF, the only thing that would be left is x and 2, right? If we're going to be factoring out the GCF. Okay, what's the GCF here? Has to be, start with the number, 4x squared. Why can't I include a y? Some of them have y's. Why don't I include y in my GCF? Yeah, not all of them have y. So here is my GCF. This would be 4x squared, which is the GCF times 1. What would this one be? What would you, if you had 4x squared, what would you need to multiply it by to give you 20x squared y? 5y, good. And here, if you have 4x squared, what would you need to multiply it by? What would be its other factor? See, this is the GCF for all of them. What would be the other factors in order to get you to that 48? Would it be 12? 12 what? Fifth y squared. Does everybody see where we're getting these numbers from? What's left? This is the GCF, right? And then this is what would be left if we were to divide the GCF into that. Okay, here, GCF, what would it be? 5, good. What else? Everybody has a b to the first power, right? Why don't I include an a? Yeah, there's no a here. Why don't I include a c? Yes, this one does not have a c. So now if I were to write the first term, 5b times what would give you the 15ab cubed? 3ab squared. You see that this is my GCF. This is the rest of what would need to be multiplied together to get that product. Okay, to get a 10a squared bc, I would be multiplying 5b times what? 2a squared c. Does everybody see where we're getting these numbers from? Okay, what about the last one? 5b times 5bc cubed. All right, very good. What about this one here? This one's a little bit tricky, huh? So this is, yes, squared. X plus y squared. Oops, not there, not squared there. Squared there. That's important. So this is the GCF because notice that it's always if you have variables, it's always going to be the smallest exponent as long as they all have it. So if I have the GCF, this is my GCF, if I have the GCF of x plus y squared, what would I need to multiply it by in order to get a cube? Just one more, right? X plus y. Here, what would I have to multiply x plus y squared by in order to get x plus y? Just one, right? Because it's already there. It's already squared. What would I need to multiply x plus y squared by in order to get x plus y to the fourth power? Squared, yes. Okay, so that's just the same exact base as x plus y. So x plus y squared times x plus y squared would be x plus y to the fourth power, right? All right, let's go on to the next page. This is we're actually now going to talk about how did we even get to this place of factoring. So this is the factoring. The first thing we do with factoring is the GCF. But let's review how we even got to the place of where we're going to divide it out. And it came from multiplying. So factoring is really division. And that's the opposite of multiplying. To really understand what we're trying to do, let's try multiplying the following. So I would suggest trying this on your own now and then coming back to see what you got. So let's imagine you all took a chance. We're going to do it together. So what did we get? Actually, I'll put it down here because there's not a lot of room. Okay, what am I going to get if I distribute the 3x squared? And by the way, 3x squared is the GCF here. It was this is called factored form. So let's talk about multiplying. When we multiply, we distribute. What would you get when you multiply everything by 3x squared? Yes? Uh-huh. We're using the laws of exponents there. Okay, let's go B. Distribution. Tell me what it is. Uh-huh. B to the third, right? Oh, b to the fourth. B to the fourth. Sorry, b to the fourth. I missed that b. B times b cubed is b to the fourth. You're right. Okay, next one. If we distribute here, what are we going to get? Plus 5x. Interesting to notice when we multiply something by 1, we get that same thing. So that's important to keep in mind when we're factoring, okay? That 1 made a difference, didn't it, having that plus 1 there. All right, here we're going to distribute. And who can tell me what you get? Yes. Y cubed. Any questions on how we got that, where we're getting that multiplication from using the laws of exponents? Okay, now here we're going to go the opposite. So when you factor, you're finding the thing that is going to divide evenly. That's the GCF, and you're going to do the opposite of multiply. We're going to take it out. So we have to think first, well, what is the GCF? What is the biggest thing that's going to go in to everything evenly? So what's the biggest number that divides into each number? 3x squared. Does everybody see where we're getting this 3x squared? So now you're going to pull out the GCF. The GCF goes out in front, and you're going to divide everything by 3x squared. What do you get when you divide this by 3x squared? Yes. Now we're dividing 3x squared into 12x cubed. What's going to be left? 4x, good. And what would happen if you divide 6x squared plus 2? Does everybody see how we got that? Factoring that out? Okay. Yes. What's that? What? Yx cubed. Because notice, I don't want to get any negative exponents. So if I divide, everything has at least an x cubed, right? Or I mean an x squared. Sorry, not cubed. X squared. So if I want to, the last one, that's the smallest. Since everything has an x, we're going to divide by the smallest exponent, since they all have it, okay? Because when you go 6x squared and you divide it by the GCF, 3x squared, you don't want to be left with a negative exponent. So x squared divided by itself would be 1, right? And 6 divided by 3 is 2. That's where we get that. Okay, let's determine first the GCF. It's going to be, let's look at the numbers first. What number divides into 6, 8, and 10 evenly? 2. Yes, now we're going to look. They all have an a. So what's the smallest exponent on the a squared. Do they all have a b? What's the smallest exponent on the b? Just b to the first, right? So we're taking that GCF out front, and we're dividing everything by that GCF. So 2 goes into 6 3 times. What happens if you have a to the 7th divided by a squared? What do you get? What's b squared divided by b? B. Yeah. Plus, so again, you could always write these off to the side, a cubed b, and divide it by the GCF, 2a squared b. What would you get if you divide those two things? You would get 4a. What happens to the b's? They cancel, right? B divided by b is 1. Okay, now we're going to take negative 10 a squared b to the 4th. We're going to divide it by the GCF, 2a squared b. Who can tell me what you get when you divide that? Negative 5b cubed. Now you'll know that you got the greatest common factor if you look at what's left and there's nothing that could divide evenly. They have nothing in common, right, that could divide out. It's kind of like when you take a fraction and you reduce the fraction. If you could keep reducing it, you didn't find the GCF, right? Does that make sense what I'm saying? Okay, what's the GCF here? Let's take it out. 5x goes into both. 5x goes in here how many times? 2x. 5x divided by itself gives us plus 1. Now, the way you could check it, does anybody know how you could check to see if that's the right answer or if that works? Yeah, you could check by distribute. So if you distribute it back in, you should get 10x squared plus 5x, which basically factoring and multiplying is like, you know, a dog chasing its tail. You're just going round and round in circles. They're different variations of the exact same problem, right? They're just different forms of writing it. Okay, what's the GCF here? You probably see that they're following a pattern here. So does anybody know what it is? 2xy. Because they all share an x, they all share a y, the smallest exponents are the first power. So we divide this by 2xy, what are we going to get? X squared y. Divide this by 2xy, and what do you get? Xy squared. Divide this by 2xy, and you get 3. Any questions on that? You see how we're dividing out the GCF? We're going to need a lot of practice with this too. Okay? So the steps for factoring out the GCF. Look at each term, find the GCF. Okay, the GCF, you're going to think about what number divides evenly into the coefficients, and if they all share the same variable, the smallest exponent. Write each term as the product of the GCF. Okay, I didn't really do that. I did that on the first page. We were just writing the GCF and factoring it out. Write the polynomial as the product of the GCF and the sum of the remaining terms, and that's what this is. This is the product of the GCF is here. This is the GCF. And then here's the remainder once we divide it out. And then multiply back to check your work. So that's what I was talking about here, is this idea of if I distribute, I should get the same exact thing. One of the things that is the most common mistake is forgetting this 1. Okay, anything divided by itself is 1. So that's why I especially pointed it out here, because if I didn't include the plus 1, I wouldn't get that last term of the 5x. Do you see that? So that's a common mistake when people divide out the GCF. They factor out the GCF. They will forget the 1 when it cancels. Okay, here's some more examples to try. In fact, I'm going to stop the video. I'm going to have you guys try this one, and then we'll share out, and then we'll go over the next part.